Okay, welcome grade 7 to your 5-2 homework on probability. As we go through these questions, if there's ones you want to skip, just fast forward through the ones you understand and stop and watch the video at ones you don't and figure out what you have to do to get the correct answer. Okay, so we're going to start at question 3 where it says Sharon created this table of list of possible outcomes for tossing a coin twice. So here's our table. The first toss, heads and tails. Second toss, heads and tails. So in here, this is our sample space. Those are our 4 possibilities. It says heads, 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 tails. And it says heads, tails here. And the question said, should it be tails, heads? And the answer is yes, it should. Because the first one should be your first coin. And the second one would be your second coin. Second coin. Does it matter in terms of it was opposite of each other, not the same? Not really. But as far as being the proper order, you should write them first event, then comma, then second event. Easy question. The second question has to do with Jeremy and spinning the spinner. So it says organize the outcomes of these 2 events in a table. So I'm going to create a table here. And up here I'm going to put tiger, bear, and monkey. And down here I'm going to put hungry. I'm just going to put H, sleepy, playful, and angry. All right, so inside here, what we have is we have our sample space that shows all of the possible combinations of these animals and their emotions. So we can count them up. We know that we have 12 possible outcomes. Okay. So the sample space is up here. This is the table. And are the outcomes independent? Well, what this means is if I have a happy tiger, does that affect having a happy bear? And the answer is no. There is no correlation between the two. So they are independent. They don't have any effect on the other events. Question 6 says Alan flips a coin and chooses one of the marbles, black, yellow, and red. Draw a tree diagram to organize it. So our first 2 events will be either heads or tails. Okay. Now, if you flip a head, you have 3 possibilities when you draw that next marble. It could be a black marble, it could be a yellow marble, or it could be a red marble. And if you flip the tails, you could have black, you could have yellow, or you could have red. So here we have all of our different outcomes are the branches. So this one right here is heads black. This one here is heads yellow. And this one here is heads red. So we can just organize that in a sample space. HB, comma, HY, comma, HR, comma. Then we have this one, which is your tails with a black marble, tails with a yellow marble, and tails with a red marble. So altogether, we have 6 possible outcomes. Our sample space for this is right here. Question 7 said the wheel is spun twice. Make a tree diagram to organize all of the outcomes of 2 spins. So let's take a tree diagram. Oh heavens, this is awful. I'm going to create, you know what? I'm going to change this. I should have told you to change this to a table. We'll do a table instead. Yeah, we'll do a table instead. A table. So as we can see, we have 3 bonuses, 3 losing, 3 try again, and 3 win. So what we're going to do is we really have an equal chance of spinning a lose, a bonus, a win, and a lose, bonus, win, and try again. So we have 4 different things that we can equally spin on this side. And down here, we have those exact same outcomes. Lose, bonus, win, and try again. So as we can see, we have I should never have put this question in there. Anyway, we have 16 different possible things that we can have in our thing. We could spin this one here, which would be a lose on the first spin. We'll call this one the first spin. And we can have on the second spin a lose. This would be lose-lose. If I spun right here, that would be a win on the first spin. Erase this part here. A win on the first spin. I'll put a comma. And on the second spin, it would have been a win. So that's a win-win. Win on the first spin, win on the second one. This one here would be a bonus on the first spin and a try again on the second spin, and so on and so forth. So it says, what is the sample space? Well, the sample space is in here, and if I want to fill it out, those would be all of my possible outcomes. So in here, this would be called your sample space. And if I wanted to create a different diagram, I could use this tree diagram, but oh my heavens, that would be one chaotic mess of a drawing. So we'll just keep it like this. You don't have to do the tree diagram, just do this, and that's all I'd require you to do. Question 8 says, Georgia spins a spinner with 4 sections, as shown, and rolls a 4-sided die labeled 1, 2, 3, 4. Well, this isn't so bad. So if I draw a tree diagram, I'm going to have 1, 2, 3, 4. This is going to be my spinner. And if I draw my tree diagram, I would create something that looks like this. And I would have 16 different possibilities. And if I want to organize them, I'd have a 1, 1, a 1, 2, a 1, 3, a 1, 4, a 1, 5. Oh, sorry, hold on. Oopsie daisy. So if I wanted to create my sample space from the tree diagram, that would be my sample space. That's all of the possible outcomes. And if I wanted to create the sum of these, I could actually, just below my sample space, add the numbers together. So 2, 3, 4, 5, 3. Okay, and the numbers below in red here are all of the sums of the two numbers combined. Okay, so the most common sum, if I was to look at these, I'd have 1, 2, 2 3s. I'd have 1, 2, 3 4s. I'd have 1, 2, 3, 4 5s, and I would have 3 6s, 2 7s. So my most common number in this is the 5. I actually have 4 of them. So 4 is the most common sum of the two numbers. Question 9 says, Jake throws 2 darts at this board. What is the sample space for this experiment? Use a tree diagram to represent the sample space. Okay. Well, obviously, if we look at B first, is each outcome equally likely? No, you're not going to hit the 10 as much as you're going to hit the 2, but we're going to put, for those 2 darts that he throws, he could have a 10, or he could have a 2, or he could have a 5, okay? And if he has the second dart, if he had a 10 on the first dart, he could have a 10, a 2, or a 5 on his second. He could have a 10, a 2, or a 5 if he threw a 2 first. And if he threw a 5 first, he could have a 10 on his second, a 2 on his second, or a 5 on his second. So for this sample space, for this experiment, use a tree diagram to represent the sample space and assume every dart hits the board. So actually, one of the things it doesn't ask for is what are the point combinations? And really, that's probably a better question. So for this one, if he threw a 10 on his first and a 10 on the second, he'd have 20 points. 10 on his first, 2 on his second would be 12, 15, 12, 4, and 7, 15, 7, and 10. So the most you could have would be 20, and so on and so forth. So this would be your sample space here. You could throw a 10, 10, or a 10, 2, or a 10, 5, or a 2, 10. So when we look at the sample space we could create from that, this would be our sample space. These are all of the possible outcomes. And is each outcome equally likely? As we said before, no. It's much more likely you're going to get 2 points because as area is concerned, the area of the blue is much larger than the area of the red and the area of the yellow. What would be an interesting area question if I actually told you what the radius was and told you this distance, and this distance. what is the area of each circle, and what is the percent likelihood of hitting those spaces? That would be a pretty good, cool bonus question. I might give you that. Who knows? Question 12 says a spinner with 3 equal sections is spun twice. Create a tree diagram to show the sample space. So, okay, here we go. So 2, a 3, and a 4, a 2, a 3, a 4, and so on. So what is our sample space? Well, if I was to draw my sample space in here, those are all the possible combinations I can have. So I have 9 possibilities, 9 possible outcomes, spinning the spinner twice. And what is the probability of having an odd product when you multiply the two spins? Sorry, first one is what is the product of each outcome? So if I was to multiply these, the product of 2 and 2 is 4. 2 times 3, the product is 6. The product of 2 and 4 is 8. The product of 3 and 2 is 6, 9, 12, 8, 12, and 16. What is the probability of having an odd product? So of all of these, this one here, 9, is the only odd product. So for this question here, it's 1 chance out of 9, which is 11.1% roughly, approximately 11.1% when you spin it twice. Question 13 says a coin is flipped 3 times. Either a head or tail appears face up. Now we've already done this one, but let's just look at this again. So use a tree diagram to show the sample space of these 3 events. So our first one is heads or tails. Our second event would be if I flipped a head first, I could have a head or a tail on my second one, or a head or a tail on my second one if I went tails first. And then if it was heads first, it could be head or tails second, head or tails second, and head or tails on each of these. So if I was to look at any of these particular ones, and let's just choose one of them. Let's choose this pathway here. If that was the path I took for the 3 coin flips, this would mean my first flip was tails, my second flip was heads, and my third flip was tails. So this was a tails, heads, tails result from 3 coin flips. If I fill in the rest of them, this is what I have. I have all of my in black, what the branch would rate. There are 8 possible combinations for flipping 3 coins. You can have heads, 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 tails, and so on, all the way down to tails, tails, tails. Question 14 says 3 spinners are divided into equal sections as shown. Each spinner is spun once. Organize the outcomes. Okay, so for this one, I'm going to use a tree diagram, and here's what it would look like. So when we finish our tree diagram, we see here that it looks pretty tight. It's not really easy to see, but I use a tree diagram because with 3 events, you can't use a table. And write the sample space for this one. So if I write the sample space for all the possible combinations, so if I do make my sample space, these are all the words I would create from those spins. And the ones that are all actually words are those ones right there. There's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of the 18 words, or 18 words that were formed were actually English words. And that's all the questions. So if you have any questions about your homework, make sure you ask me. If this video didn't help you, hopefully it did. Make sure you copy down all of the answers that you didn't get correct. And tomorrow when I do a homework check, there shouldn't be any excuses for why you didn't get your homework done.